Hi everyone, I'm going to go over question 54 from the Chapter 7 Bingo problems. This problem has to do with a skier who is 65 meters high on this ski slope, and the mass of the skier is 60 kilograms. And in part A, it says if friction forces do 10.5 kilojoules of work on the skier as she descends, how fast is she going at the bottom of the hill? So the equations we'll need our energy equation. So kinetic energy equals potential energy plus work. Potential energy equals mgy, and kinetic energy equals 1/2 mv squared. So to solve this, let's combine all these together into the component. So we'll end up with 1/2 mv squared equals mgy plus work. And now what we can do is we'll rearrange everything because we're looking for the velocity. So let's isolate that. As we do that, we'll end up with v squared equals mgy plus w 2 over m, and then square root so now what we need to do is I guess we can simplify this a little bit. So v equals square root 2 times, we can cancel the m from here, so it'll be gy plus work over mass. Don't have to do that, but it helps in my brain. I don't like fractions. So anyway, now all we need to do is plug in the values that we know. So we know that the work is 10.5 kilojoules, which equals 105,000 joules. So we know that. We know gravity, we know y, and we know the mass. So we know everything else to find the velocity. So when we plug everything in, we get 2, so square root of 2 times 9.81 times 65 plus 105 over 60. Okay, so when we plug that into our calculator, we end up getting that the velocity is equal to 30.42 meters per second. So that's it for part A, but we still have 2 more parts. We have B and C. So for part B, it wants to know, so it says, now that the skier's at the bottom of the slope and moving horizontally, this person crosses some soft snow with a coefficient of kinetic friction of 0.2, and that soft snow is 82 meters wide, and the air resistance is 160 newtons. And then they want to know what the velocity is after the patch. So after all these resistances, what's the velocity? So at this point, the nice thing is there's no potential energy because you're moving horizontally, so it's all kinetic at this point. So we know that K2 equals K1 minus work. We also know that work equals force times distance, and we know that the kinetic energy equals 1/2 mv squared, so we know 1/2 mv squared equals 1 squared minus So there it is, kind of decompressed. We also, so with our force, we know that we need to add in the air, we need to add in the coefficient of kinetic friction. So that means that F equals, so it's going to be the air, which is, we'll just say F air, plus U, okay. And then that also needs the normal force of mg. So that's our force. Now what we need to do is put all of that together. So really, I guess we can just, well, I guess that all equals F of D. Or no, F, and then we'll throw this in, so okay. So now what we can do is we can solve. We want to know V2, right? Because this is our initial velocity. We want to solve for this. So just rearrange everything, do some math. It's just some simple algebra. We get V2 equals 2 times 1/2 V squared 1 minus the friction of the air over the mass plus the coefficient of friction times gravity times the displacement. And so to get rid of the squared, we just square root that. And then now what we can do is we can plug in everything we have. So we know that the first velocity is what we already found, the 30.42. So we know that V squared equals square root 2 times 1/2. And then minus, you know, the air, it said was 160 newtons. The mass is 60 plus the coefficient of friction was 0.2. Gravity is 9.81. And the displacement was 82 meters. So have that big old thing, put that in the calculator, and V2 equals 12.9 meters per second. All right, so that's it for part B. So now part C wants to know, so the skier hits the snowdrift and goes 2.5 meters into it before stopping. They want to know the average force exerted on the skier by the snow as it stops her. So we know that in this place, the work to stop the skier is going to equal the kinetic energy of the skier, right? Because as one goes to 0, the other one at the same time is growing. So it's, or sorry, not growing, but they are proportionate to each other. So work equal K. You could say like plus U, but we know that U is 0, so it's just work equals kinetic energy. That's a better way to describe it. So we also know, once again, that work equals FD, and K equals 1/2 mv squared. To solve for the force, we get F equals 1/2 d mv squared. Now we just plug everything in. Force equals 1 over 2. That displacement was 2.5 meters to stop. Mass was 60. And the velocity 2. But the velocity that she's going, we know was 12.9 that we just found in part B. And that's squared. So throw that in the calculator, we get the force is equal to 1,996.9 newtons. So F equals 1996. So those are the answers for all 3 parts. Thanks for watching. I'll see you in the next one.